All right, let's talk about AWS Lambda. So you've written your awesome serverless function, you've deployed it up to the cloud, that's great. But now what? How do you actually get that code to run? Well, that's exactly what we're going to get into today, the whole world of Lambda invocation.
I mean, think about it. Your code is just sitting there waiting. It's this little bundle of potential, but it can't do anything by itself. It needs a kick, a trigger, some kind of signal to get started. So how do we give it that signal? How do we tell our code, hey, it's go time?
And that signal has a name. It's called an invocation. I love this analogy of a spark. It's the perfect way to think about it. An invocation is just the action of triggering your function. And you almost always do that by passing it some data, which we call an event. This action, this spark, is the fundamental thing that makes all of serverless work.
Now, the moment you decide to invoke a function, you're faced with a choice. It's like a fork in the road. And the path you pick here has a huge impact on how your whole application is going to behave. We're talking about synchronous versus asynchronous invocation.
This slide just nails the difference. A synchronous call, that's like a phone call. You dial, you wait for an answer, you have your chat, you hang up. The key is you are blocked until you get that response. On the other hand, an asynchronous call is like a text message. You send it, and then you put your phone away and get on with your life. You trust that it'll get handled eventually. This simple difference is why they're built for totally different jobs. That API your user is waiting on needs the phone call, but a background job, it loves the freedom of a text message.
So let's dig into that phone call model first, synchronous invocation. This is the most straightforward way to talk to your function. You ask a question, you get an answer. Simple as that.
So to get a little more formal with a synchronous invocation, whatever is calling the function, your API gateway, a script, you in the AWS console, it sends the event and then it just waits. It's literally holding the line, waiting for your function to do its thing, finish up, and send a result back. And if you were to do this from the command line, this is what it would look like. Now you can see the function name and the payload, but the most important part here is this, -invocation type request response. That is the magic flag that tells Lambda, hey, I'm waiting. Don't hang up until you have an answer for me.
Okay, this is a super important point, so listen up. When you call a function like this, getting a status code 200 back only means one thing. Lambda was able to run your function. It does not mean your code worked. If your function actually threw an error, that error message is going to be tucked away inside the response payload. It's on you as the caller to crack open that response and check if things actually went according to plan.
All right, let's switch gears and look at the other path, the text message model. This is asynchronous invocation, and it's where you can build some seriously flexible and resilient systems by decoupling the request from the actual work. Just look at this flow. It's totally different. The client sends the event, and Lambda's first move is to stick it in a queue. Then it immediately replies with a status code 202, which basically means, yep, got it, thanks. And your client is now free to go do whatever it wants. It's done. Meanwhile, behind the scenes, some other process in the Lambda service will come along, grab that event from the queue, and then run your function. Your client has no idea when that happens, only that its request was accepted.
And the code reflects this perfectly. It looks almost the same as the last one, with one tiny but critical change. The -invocation type is now set to event. That's you telling Lambda, hey, just take this event and deal with it whenever. I'm not going to wait around for a response.
And here's where async is just a game changer. Error handling. If your function fails, you don't have to write your own complex retry logic. Lambda just does it for you. By default, it'll try again 2 more times, with waits in between. And if it still fails after all that, the event isn't just lost in the ether. You can set up what's called a dead letter queue to catch these failed events so you can figure out what went wrong later. It's this incredible built-in safety net.
So we've talked about calling our functions directly. But the real magic of serverless happens when you let other AWS services invoke your function automatically. This is the absolute core of what we call event-driven architecture.
So how does this automation even work? Well, there are basically 2 models. First, you've got a push model. Think about S3. You upload a file, and S3 itself pushes an event over to your Lambda function, triggering it. Then you have the pull model, which is used for things like SQS queues or Kinesis streams. In this case, the Lambda service itself is constantly asking the queue, got anything new for me? Got anything new? We call this polling. When it finds messages, it grabs a bunch of them and then calls your function with that batch. So the real difference is who starts the conversation, the service or Lambda itself. With all this automation and all these retries happening, you might be thinking, what about safety? What happens if something goes wrong over and over? Or worse, what if I accidentally code an infinite loop? Well, it turns out Lambda has some really clever guardrails built right in.
So here's just a quick cheat sheet to recap what we've learned about error handling. Synchronous calls, it's all on you. You have to build the retry logic. Asynchronous, Lambda's got your back with automatic retries. And for those event sources from streams, it's even more robust. Lambda will retry the entire batch of records over and over until it works, or the data gets too old. It's designed to not lose your data.
Ah yes, the classic serverless nightmare scenario. An S3 upload triggers your function. Your function processes that file and helpfully writes the output right back into the same S3 bucket, which, of course, triggers the function again and again and again, forever. How does AWS stop you from getting $1 million bill?
The answer is this number, 16.
Because Lambda has a built-in recursive loop detector. It's smart. It watches when one service triggers another in a chain, and if it sees the exact same chain of events for the exact same reason happen more than 16 times in a row, it basically says, well, hold on, something's not right here, and it just breaks the loop. It stops the next invocation from happening. It is an amazing account-saving feature that you get for free.
So, we've gone through a lot. We've got synchronous calls, asynchronous events, automated triggers. The big takeaway here is that you now have a whole toolkit. And the key to being a great serverless developer is knowing which tool to pull out for the right job.
And this table really lays it all out pretty clearly. Is a user staring at a loading spinner in their browser? You absolutely need a synchronous invocation. Are you kicking off a long background job, like processing a video? Go asynchronous and free up the caller immediately. And are you trying to drink from a data fire hose, like an SQS queue? Let an event source mapping do all the heavy lifting of polling and batching for you.
See, understanding invocation isn't just some boring theory. It is the absolute key to designing serverless applications that are robust, scalable, and cheap to run. You now have the fundamental patterns you need to build almost anything you can imagine. So the only question left is, what are you going to build? Thanks for tuning in.